Good morning, everyone. Today I want to present the last lecture on bonding in metal complexes, 2 chapter. Here I will discuss the Orgel diagrams for different term splittings. And before that, in last class we have discussed the crystal field effect on F term. Crystal field effect on F term. So that again, crystal field effect on D term once I will brief, because these splitting patterns of F term and D term are summarized in the Orgel diagram. So just briefing of crystal field effect on D term, F term may help for the next topic. So coming to the D term, crystal field effect on D term, where here we has totally 8 diagrams, 8 splitting diagrams we can observe as the D1, D9 and D4, D6 electronic configurations will have D term as in ground state term. D term as ground state term. So 2D term in D1 electronic configuration has splitting of T2G EG, 2 T2G in lower energy state, 2 EG in higher energy state in octahedral crystal field. That same when we explain in tetrahedral. In tetrahedral, the lower energy state will be EG and the higher energy state will be T2G, 2 T2G, right? So this is in tetrahedral crystal field. And same when we extend for the 2D term, D9 electronic configurated, then the splitting pattern in octahedral as reverse, right? As the D9 configuration is whole inverse for the D1 configuration, the splitting patterns in octahedral tetrahedral will get reversed into the 2D term of D9 electronic configuration. So once if it is come for the octahedral crystal field, the lower energy state will become 2 EG and the higher energy state will become 2 T2G, as it is reverse of this. And if we want to explain the tetrahedral will have lower energy state of T2G and higher energy state of EG. This will be reversed to the tetrahedral splitting pattern of 2D of D1 electronic configuration. Like this we have, and extending these splitting pattern for the D5 5D term of D6 electronic configuration, where the splitting will be in octahedral will be similar, octahedral and tetrahedral will be similar with the D9 configurated 2D term, where these two are, right? We know that Dn, so D5 minus n, D10 minus n will have similar splitting, and Dn plus 5 plus n will have similar pattern. So D5 minus n, D10 minus n will be D to the power of 9 electronic configuration. D5 electronic configuration will be D4 it is. D4 configuration. These two will have similar splitting patterns, such as the lower energy state will be 5 EG and the higher energy state will be 5 T2G. Here in tetrahedral there will not be any G subscription, it will be there. And when it comes to an tetrahedral, it would be reverse to the octahedral. This is the octahedral crystal field. Now coming to the tetrahedral crystal field, it would become 5T2 and 5E in excited state. So extending this towards the 5D of D6 electronic configuration, then the splitting will have higher energy state. It is reversed to this and similar to the D1 electronic configuration. So for the lower energy state will be T2G, the higher energy state will be the EG, 5EG. And once if it is into a tetrahedral, lower energy will be E, higher energy will be 5T2. Thus 8 diagrams, 1, 2, 3, 4, 5, 6, 7, 8. Right. These are 8 diagrams are showing the D term affected by the D term splitting affected by the crystal field. Right. Crystal field affecting D term effect splitting will be like this. Right. So same when we discuss into an F term, crystal field effect on F term. F term, 3F term of D2 electronic configuration has splitting. The higher energy state will be 3A2G and next lower energy will be 3T2G and lowest energy state will be 3T1D, and this is in octahedral crystal field. In tetrahedral crystal field it will become reverse. Where lower energy will be 3A2 and next higher energy will be 3T2. The highest energy level will be 3T1. Right, this is in tetrahedral crystal field. Same the concept when we extend towards the 3F term of D8 electronic configuration. It has inverse to the D2 configured 3F term. So where the higher energy state will be 3T1G, the lower energy state will be 3T2G, lowest energy state will be 3A2G. It is an octahedral crystal field. When it comes to a tetrahedral crystal field, the octahedral will be get reverse. So where higher energy state will be 3A2, the lower energy state will be, next lower energy state will be 3T2, lowest energy will be 3T1. This is in tetrahedral crystal field. Same to that, when we extend for the next two electronic configurations, D3 configured 4F term of D3 configured, where this has similarities with D8 electronic configuration, where the high energy state will be 4T1G, lowest energy state will be 4A2G, next lower energy state will be 4T2G in octahedral crystal field. When it comes to tetrahedral crystal field, highest energy state will be 4T1 and lowest energy state will be 4A2, next higher energy state will be 4T2. where here the splitting pattern will be reverse to the 4f of d3 but similar to the 3f of d2. So the higher energy state will be a to g, 4 a to g. The next higher energy will be 4 t to g. Lowest energy state will be 4 t1g, and this is in octahedral crystal field. Coming to the tetrahedral crystal field, the higher energy state will be 4 t1, there is no g subscription, and lowest energy state will be 4a2. Next higher energy state will be 4t2. Like that, the 8 diagrams of F orbital splitting pattern shows the crystal field effect on F term, and these splitting patterns of D term and F terms are summarized or compressed in a simple and each one diagram, right? In 2 diagrams, these 8 of each term splitting patterns are explained in Orgel diagram. Now coming to the Orgel diagram. Orgel diagrams, where in Orgel diagrams it is an summary or summary of D and F terms splitting in each one diagram. It is a summarization for each. Before this Orgel diagram, we has D term splitting pattern to explain crystal field, octahedral tetrahedral crystal field effect on D term. For all 4 electronic configurations, we has 8 diagrams. Same to that, 8 diagrams of F term splitting will shows the tetrahedral octahedral crystal field effect on F term for the 4 different electronic configurations. Thus 8 diagrams of D and F terms are summarized in each one diagram, and this summarization will give you clear and exact explanation of absorption spectra of their complexes and transactions, electronic transaction absorption spectra can be explained here easily. And not only the summarization, he also extends his splitting diagrams for D5 electronic configuration, where in D5 electronic configuration actually we has ground state term of 6s, and this 6s never be have any splitting. We know that the S term with the crystal field effect, there will not be any splitting possibility. So in D5 electronic configuration, to analyze the practical data, in view of practical data, the Orgel extends the crystal field effect on from the ground state term to next higher energy term. The ground state term here it is sextate spin multiplicity. S term is the ground state term, and he extends the crystal field effect on ground state term to next higher energy states of quadrate spin multiplicity terms. And how he extended it, and with this extension, how would be the pictorial diagram we are going to see. And he also explained, the Orgel explains that in effect of crystal field, the structures, the straight lines what we are showing in excitation of newly generated energy levels, we are showing the straight lines. But actually, to when examining the practical data, the excitation curves, newly generated energy level excitations may not be linear, it may be somewhat curved, right? So he also discussed the curved natures, why the curved natures are taking place. Also he discussed in the Orgel diagrams, right? So the all will be explained in Orgel diagram. Now coming to the and to extend the Orgel diagram, he classifies the uh, three groups of electronic configuration. He classifies the electronic configuration of metal complexes in three groups as such: D1, D9, uh, D4, D6 as in one group, where it consists D term as a ground state term. D term as the ground state term. This is one group, and in second group he has D2, D8, D3, D7 configurations, where the ground state term will be F term. Ground state term will be F term. And he also has one another group, special group for D5 electronic configuration, where the ground state term may be the S6, but in extension of S6 he also explains the uh, next higher energy levels, and in the next higher energy levels, the quadrate high spin multiplicity higher energy levels carries 4G, 4P, 4D, 4F, and these four quadrate next higher energy level from the ground state also he incorporated, and these how does affected these terms, how they are affected by the crystal field, he will discriminate, he will discuss, and with this discussion he concludes the Orgel diagrams, right? So here we start each one Orgel diagram. The first one, Orgel diagram for D1, D9, D4, D6 configurations. So we know that the D1, D9 has the ground state 2D as an ground state term, and D4, D6 has an 5D as an ground state term. So these four electronic configuration having D ground state term, he chosen the four electronic configuration in one group. And here to explain the Orgel diagram, he taken that an vertical line in middle and horizontal line in bottom. The horizontal line shows the crystal field energy scale, and the vertical line shows the term energy. And there at middle he considered the D term. In explaining of this particular group, he considered this ND term. He generalized the two ground state terms 2D 5D as ND, where N is equal to 2 for D1 D9 configuration, where N is equal to 5 for D4 D6 configurations, right? In view of that, this particular ground state term at middle now it will be in zero energy state. With the zero crystal field, the D term will be in the exact state of ND term. When crystal field influencing on D term, there the splitting will take place. And the splitting will be like this. Where the middle state indicates the ground state of the term, ground state energy of term 0. And here this particular pattern, this straight line indicates the NT2G state, and this particular straight line indicates the NEG or NE or NT2, right? NT2. And this splitting pattern for D1 D6 configured in octahedral crystal field, the particular pattern of splitting will take place. And for D4 D9 configured tetrahedral crystal field splitting pattern will be shows by this half pictorial diagram, Orgel diagram, right? Isn't it? We know that in D1 configuration of 2D term has lower energy state of 2 T2G and higher energy state of 2 EG in octahedral phase. And here that showing D term of D1 configuration, lower energy state is T2G, higher energy state is EG. Same to that, the D6 configured D term, has same lower energy state of T2G, higher energy state of EG. So that is shown here, lower energy state of T2G, higher energy state of EG. And when it comes to an tetrahedral, these are in octahedral. When it comes to an tetrahedral, D term of D9 configured, lower energy will be T2, higher energy will be E. That is what D9 configured tetrahedral crystal field has lower energy state of T2, higher energy state of E. Same to that, the D term of D4 configuration in tetrahedral, lower energy state will be T2, higher energy state will be E. And here that's showing lower energy state of T2, higher energy state of E. Like this, the half pictorial diagram of Orgel diagram will indicate all 4 electronic configured D term splitting pattern into different crystal fields, right? So next, coming to the next half, it is showing that reverse to the Orgel diagram. Right here it would be have N EG in lower energy state or N in lower energy state. In higher energy state, N T2G or N T2 in higher energy state. And this particular pattern splitting will indicate the D1 D6 configured tetrahedral crystal field effect will be shown, and for D4 D9 configured octahedral crystal field effect will be shown here, right? On D term, on ground state term of D, D1 D6 configured ground state term of D, the tetrahedral splitting pattern shown here, right? Here once we go for the previous class, it is shown that the 2D term of D1 configuration has lower energy state of E and higher energy state of T2. Here D1 configured D term in tetrahedral configuration, it has lower energy state of E, higher energy state of T2. Same to that, the D6 configured 5D term has lower energy state of E, higher energy state of T2 in tetrahedral configuration. So here thus showing. And same D4 D9 configured D term in octahedral crystal field has a lower energy state of Eg, higher energy state of T2G. Here in octahedral crystal field D9 configured, right, 2D term has lower energy state of E, higher energy state of T2. Same to that, D term of D4 configured in octahedral crystal field has lower energy state of E, Eg and higher energy state of T2. That Eg, T2G for the D4 D9 configuration. Like that, summarizing the all 8 diagrams of crystal field effect on D term is summarized in a simple one diagram. This was given by the Orgel to summarize or to simplify, to make the convenience of splitting patterns of D term of terms, right, or terms. And here once we observe the splitting patterns, we can give that the D1 configuration and D6 configuration having same splitting patterns of D term, there the D1 D6 are called as normal configurations will be called as normal configuration. And from the whole formalism advantage the D4 and D9 are the whole inverse configurations for D1 and D6. Therefore, the D1 D9 configurations called as whole inverse configurations. Will be said as whole inverse configuration, as the D1 D9 configuration has exactly reverse splitting patterns from the D4 D9 are the whole inverse splitting patterns. They has whole inverse configurations with the reverse splitting patterns with the D1 D6 D term. So they are said to be as whole inverse configurations, right? So this is what the first diagram, and the convenience what we have seen is all the 8 diagrams are summarized in one pictorial diagram. That is the one convenience, and the other convenience is we can exactly notify the electronic transactions electronic transitions with the help of Orgel diagrams. That is in D1, D4, D6, D9 configurations, we either may have n Eg to n T2G transaction we can observe, or n T2G to n Eg transaction we can observe. In the D1, D9, D4, D6 configurations, we can observe one transaction, the electron transaction, that may either from the n Eg to the n Eg ground state to the n T2G higher energy state, or it may be the transaction from n T2G to n Eg, or in another word we can write that n E to n T2, n T2 to n T2 to n E. We can observe such single transaction from ground state to higher energy state, right? The transaction energy states we can here clear picturely we can indicate, right? So that is the one advantage. Another advantage we can have from the Orgel diagram. So in continuation of this first Orgel diagram, we will go with second Orgel diagram. Orgel diagram for D2, D8, D3, D7 configurations. So in this all four electronic configurations, we may have the ground state term of F, where D2, D8 will have 3F as in ground state term, and D3, D7 will have 4F as in ground state term. So these ground state terms influenced by the crystal field effect. There are 8 pictorial diagrams we has, and thus 8 pictorial diagram. Now we can summarize or into one single Orgel diagram. So to have this here, we will summarize these two terms in an NF, in generalization of F term in terms of NF, where n is equal to 3 for D2, D8 configuration, n is equal to 4 for D3 and D7 configurations, right? So writing the picture of Orgel diagram, again it has vertical line, horizontal line, and it has F term, NF term. In NF term splitting, we know that it has three energy states, newly generated energy states. So there will be three lines we have to draw. So it, and this may be an 0 level, so it would be another line, straight line. So we know that the F term upon crystal field, it has three newly generated energy levels such as A2G, T2G, T1G, right? So here we can observe that the crystal field, this is an term energy scale, this is an crystal field energy scale, and here as we are extending the crystal field effect on term, the terms what we have, the newly generated terms what we have, they may not go straight scale. They will be have some curvature. There will be existing of some curvature, and thus curvature is explained for F term is due to the interaction of newly generated levels with next higher energy term. Next energy term for the next higher energy term in these four electronic configuration, we will observe that 3p np, we can observe the next energy level term where this going to interact with the newly generated energy levels. On the interaction of these, what happens is the splitting, the excitation energies may be become somewhat curvy in nature, will become somewhat curved, may not be have exactly straight line, it would have some curve, right? And here this particular energy state may be Na2G, and this is Nt2G, this is Nt1G, and same to that, this would be Na2G or Na2, and this is Nt2G or Nt2, and this is T1G or Nt1, where in this particular scheme of pattern we can observe in D2 D7 configurations of NF term, and in octahedral crystal field, and D3 D8 of in tetrahedral crystal field. You can observe this particular splitting pattern, and the reverse splitting pattern of it can be observed in D2 D7 of tetrahedral crystal field, and D3 D8 of octahedral crystal field. We can observe this. So not when it is having the interaction of this particular n term newly generated energy level will be Nt1G of P. Nt1G of P will be there, and thus Nt1G of P getting interacted with A2G, Nt1G of P in interaction with same spin multiplicity Na2G, where crossover occurs, right? What happens is when the crystal field energy, once we are extending, the straight line of A2G will cross over the Next higher energy state, newly generated energy state of N T1G of P get crossovers, will crossovers 1 by N. This crossover will slightly modifies or curvatures the T1G energy state will be slightly curves, and same effect we can also observe into the next half of the picture. We can also observe, uh, thus it means the D2 D7 configured in tetrahedral crystal field also, the T2 T1G of F term will get influenced by the uh, next arising energy state of NP's term, that is N T1G of P will get interacts with the T1G, where here the interaction is in between of the interaction between N T1G of P and N T1G of F term, where the terms where new these new energy levels will go away from one to other, will go away from one to other. This is called as mixing. Where same spin multiplicity, same orbital multiplicity terms, when they are getting in interaction, they will get repulsion, and they will go away from one to other. There the curve, the straight line of those energy states will be get curved, and the curve will be for the T1G state of F will be towards the lower energy state, and T1G state of the P will be get higher energy level. Thus will be takes place, and the curvature will be same extension. How effectively the T1G of F term getting lower its energy, same effectively the T1G of P will be get excited. The repulsions will be same, and these repulsions will be reversible, will have reversible or inverse proportional, will have inverse proportional with the extension of interaction. So how lesser interaction takes place, that far mixing will take place. How more greater closerly when they interact, the mixing will be lower and the curvature will be become slight, right? So that's how, and not only this, here also the curve with respect of here, the energy state here also get curves, and this also will be in extent, x level it will be get extended, right? So that's how the splitting pattern is there into the 4 different electronic configurations of D2, D3, D7, D8. In D2, D3, D7, D8, the effect of crystal field will be takes place on F term, but the F term, upon interacting with the next energy term of NP, where there will be, in case of D2 D7 octahedral, D3 D8 tetrahedral crystal field, it would be have crossover nature. It will be observed. Crossover phenomena is observed, wherein D2 D7 tetrahedral crystal field, D3 D8 octahedral crystal field, the mixing phenomena can be observed in the interaction between F term newly energy states and P term energy states, and that's how the splitting and where the crossing why it is taking place is clearly explained by the Orgel diagram. This particular explanation we didn't see in the last simple crystal field effect on terms, right? So here the Orgel extends thus why the uh, lines, why the newly generated uh, energy level lines are getting curved. Here we can clearly observe, and here we can say that the D2 and D7 configurations as normal configurations, as they have same similar splitting patterns. The D2 D7 configurations will be called as normal configurations. When it comes to an D3 D8 configurations, there will be splitting pattern or reverse to the D2 D7 configurations. So far these two configurations will be called as whole inverse configurations. Whole inverse configurations, right? That's how the second Orgel diagram. Now next we will go with the third Orgel diagram. Third Orgel diagram, where in the third Orgel diagram will explains the splitting pattern or crystal field effect. Crystal field effect on D5 configured metal ions. In D5 configured metal ions, how does the crystal field effect take place? Here the Orgel diagram will explain, where the D5 electronic configuration will have 6s as an ground state term. 6s as an ground state term, where the 6s upon the influence of weak crystal field, it never be get in splitting. Since it is a singly degenerate state or non-degenerate state, there is no splitting can observe. So the transaction, the practical result suggesting transaction now can be explained when we extend the crystal field effect on next level of terms. Next higher energy level of terms are here. We will observe G, 4G will be the next. 4G, 4P, 4D, 4F are the four next higher energy level of terms, where in thus the electron excitations may observe to have different transactions and to have absorption spectroscopy. So thus crystal field effect extension is studied by the Orgel diagram, where the Orgel diagram may be like this. And this particular lower energy considered as ground state term, and its extension on crystal field energy. On crystal field energy scale, the 6s term will be have no splitting, So as it is having no splitting, we will say that it is horizontal. The energy scale of 6s will have horizontal line, and the newly generated energy level will be written as 6a1g, and thereby we has next higher energy level, that is 4g. There it followed by 4p it has, and thus followed by 4d, and it followed by the 4f, 4f, like this. 4 quadruple spin energy levels are there, and in this the 4g term, upon influencing on crystal field effect, it has 4 energy levels, newly generated energy levels, in which there are 4a1g, 4a1g and 4eg, and it followed by 4t1g and 4t2g will be there, right? This is 4t1g, this is 4t2g. Like this, all 4 energy states will rise from the G term. This is just and coming to the D. Before going for the B, we will discuss the D, where it has another horizontal line in the state of Eg, 4Eg of D term, and from that it also has T2G energy level, 4 T2G energy level from the D term, and the F term also having one horizontal energy level, that is 4A2G, and it follows by 2 triply degenerated energy levels, that's T1G, T2G, 4T2G, 4T1G of F term, and the P term will have T1G, and thus T1G will raise its energy till this 4T1G of P term, right? So that's how the Orgel diagram of D5 configuration, and that's how the crystal field effect on D5 configurated terms can be observed, right? And here, if we go for the energy ordering, if we see the energy ordering of terms after 6 state, the 4G should follow 4F, there by 4D, and there by 4B. As per the Ohm's rule, the energy order should be 6S followed by 4G followed by 4F followed by 4D followed by 4P has to be there. But this particular d5 electronic configuration terms also violates the Ohm's rule. So far it has the energy ordering of 6s followed by 4g. Thereafter it will become 4b, and next it would be 4d, and it followed by 4f. Right. Orgel diagram, we can observe two things. One is the electronic configuration and the electronic transitions in d5 electronic configurations are forbidden, will be the forbidden, since the ground state term is sextate, and from the sextate ground state term to electronic excitations to the quadrate terms will be spin forbidden, right? So that is the one. And the octahedral crystal field and the tetrahedral crystal field will have same splitting pattern, will have same type of splitting patterns. So with these 2 points I can conclude, I will going to conclude the d5 electronic configuration Orgel diagram. So one more time, if I brief the Orgel diagrams, the Orgel diagrams are actually summarizing the all d orbital, f orbital splitting patterns to have the convenience in exploiting the absorption spectroscopy or electronic spectroscopy. Transactions in absorption spectroscopy is clearly explained from the Orgel diagrams. For thus convenience, the Orgel diagrams are proposed, and to summarize all the diagrams also it has one of the advantage. And here we also can explain the d5 electronic configuration Orgel diagram, where it is d5 electronic configuration has the sextate S ground state term symbol, where the S ground state term symbol upon crystal field effect never have any splitting. But in analysis of experimental data, in view of experimental data, the crystal field effect is somewhat extended in d5 electronic configuration. That extension of crystal field effect we will going to see as one of the Orgel diagram. And here the Orgel diagrams are 3. By making 3 electronic configuration metal ion groups, he proposed the 3 diagrams in which one group of metal ions are having d1, d9, d4, d6 configured, where the metal ions will have d as in ground state term symbol. The second group will have d2, d8, d7, d9, and in thus configured metal ions, F term will be the ground state term symbol. And the third Orgel diagram about the d5 configured metal complexes. So coming to the first Orgel diagram, in first Orgel diagram it is explained for the metal ions consisting d1, d9, d6, d4 configurations, where it has d term as in ground state term. So in d1, d9 it has 2d term, d4, d6 has 5d term. So generalizing these d2, 2d term, 5d term, it has termed as nd, where n may be equal to 2 for d1, d9 configuration, n is equal to 5 for d4, d6 configurations. So taking generalized n term, here to exploit the Orgel diagram, we have 2 scales. One vertical scale showing the term energy from bottom to top, it is increasing the term energy, and one horizontal scale it has and thus horizontal scale shows the energy of crystal field, right? Energy of crystal field. From the middle, the right side indicates the one crystal field, left to right it increased, and for the left diagram it is increased from right to left, increase in crystal field energy. In this, the D term, upon splitting, we know that it has T2G energy level and EG energy level. And when it comes to the picture of this, it is showing the two lines, which are one indicating the energy of EG state. The other line is indicating the T2G energy state or T2 energy state. The right side diagram of this particular half diagram of Orgel diagram will shows the D1 D9 octahedral crystal field effect on D term, as well as it shows the tetrahedral crystal field effect on D4 D9 term, D term, configurated D term effect by the tetrahedral crystal field will be explained here, explored here. And coming to the left side diagram, it explains the D1 D6 configured D terms affecting by the tetrahedral crystal field, tetrahedral crystal field effect on D1 D6 termed D1 D6 configured D term effect will be explained here. And it also explains the octahedral crystal field on D4 D9 configured D term effect will be explained here, right? Explained here. So when we observe this particular picture of Orgel diagram 1, it is confirming that the D1 D6 configurations having same type of splitting patterns, has the same type of splitting pattern. So having same splitting patterns in D1 D6, the configurations are termed as normal configurations. And when we compare the D4 and D9 configurations with D1 D6 configuration, they have reverse, these D4 D9 having reverse splitting patterns with the D1 D6. So these are called as inverse configurations. And here, with the help of the Orgel diagram, we can propose the electron excitations in D1, D9, D4, D6 electronic configuration. Electron excitations we can propose as that electronic excitations may be from NT2G to NEG or NT2 to NE. Thus excitation may take place. Otherwise, the excitation may be from NE to NT2G or NEG to NT2G. Such single excitation is observed in absorption spectroscopy of these four electronic configured metal complexes. Thus, convenience of showing the electron excitation, proposing of electron excitations is there in Orgel diagram. So far, it is more popular. Right. Coming to the next Orgel diagram, showing for D2, D3, D7, D8 electronic configurations. Crystal field effect, where D2, D8 will have 3F as a ground state term, D3, D7 have the 4F as a ground state term. Generalizing the 3F and 4F terms in an NF term, where N may be equal to 3 for D2, D8 configuration, N may be equal to 4 for D3, D7 configurations. So here, actually, we has for F term, we know that the F term will have A2G and T2G and T1G. And this F term, when we write the crystal field effect on F term, the F term energy states, newly generated energy states, has interacted with the next level of term. The next level of term here we has P term. For all these four electronic configuration, we has P is an next level of energy term. Thus, energy term is have returned as an T1G non-degenerated energy state. We know that upon the crystal field, the P will never be getting splitting. It has just excitation, and thus can be written as T1G state. So the crystal field affecting on F term generated newly energy states will has interaction with the next energy level of P of 1G term. P of 1G term. This is termed as T1G of P. This is termed as T1G of F. Thus, interactions between these energy to this can be taken place, and thus interaction here clearly explained into the Orgel diagrams. Right. Again, taking an horizontal diagram, horizontal scale, which showing the energy scale of the F term, and one horizontal scale, which explaining the energy scale of the crystal field. Right, crystal field energy. So term energy in a vertical line, crystal field energy in horizontal line. Initially, if we are drawing the F orbital splitting, the F orbital splitting has A2G, T2G, T1G. Thus, A2G, T2G, T1G in an if it is an octahedral, when it comes to tetrahedral, thus reverse it takes place. A2G in lower energy, T2G in next higher energy, T1G in highest energy level. It will be observed, and here the next level energy from the F term, it has an P, and thus P energy didn't has an horizontal extension of energy with the scale of crystal field. It didn't has the horizontal line. It has curved line. The curved line of P term is due to interaction of A2G with T1G of P, A2G of F term and T1G of P term. When we extend the A2G line, A2G straight line, thus upon increasing the crystal field energy, the A2G will extend it, and thus A2G extended line will cross over onto the T1G of P. So upon crossover with T1G, the T1G will get slightly curved. This crossover, this crossing the one state by other will be called as crossover phenomena. And similar, we can see in the next also the similar energy, similar terms of T1G of F term, T1G of P. Once they are getting an interaction, the interaction will be said as mixing. In this interaction, the energy states will be get repulsed one by other, where in repulsion the T1G of P will exert its energy level, and T1G of F will diminish its energy and will get curved. With the respect of this curved nature, here also we have to project the curving nature. Will be takes place here also curved nature, right? And the mixing and crossover is different. The mixing when it takes place, because when there are same spin velocity, same terms are getting in interaction, there will be mixing it takes place. When same spin velocity, different terms getting in interaction, there will be crossover it takes place. So here T1G, N T1G, N A2G. The spin velocity may be same, N, but the terms are different. So far here crossover taking place, and in this case the T1G of P, T1G of F, their spin velocity is same and terms also same. With the same spin velocity, same terms, when they are getting interacted each other, the mixing it takes place, get repulsed one by other and gets away from one to other. That is what the crystal field effect it takes place in D2, D8, D3, D7 configurated in configurations, right? So here we can observe the two more things, such as D2 D7 are set to be as normal configuration, since the D2 term splitting patterns, D7 configured F term splitting pattern is one to other same. So far it called as normal configuration. From these configuration to D3 D8 configurations having reverse splitting patterns. So far D3 D8 configured term will be called as whole inverse configurations. D3 D8 will be called as whole inverse configurations, right? Coming to next Orgel diagram for D5 electronic configuration. In D5 electronic configuration, we has ground state term symbol of 6s. 6s we has as a ground state term. So this 6s upon crystal field effect, the S term, as it is a non-degenerated, singly degenerated, having only single orbital multiplicity, it never go under in splitting. So the crystal field, so the electron excitation may not be takes place, should not be takes place when crystal field affecting on only ground state term. But in practically the phenomena is different, the picture is different. To explain the practical data, we have to, the Orgel will extends the crystal field effect on next higher energy terms. Here we will observe the 4 next higher energy terms. Here we will have 4 from 6 state to it has next higher energy terms of 4G, 4F, 4D and 4P. These 4 quadrate spin multiplicity states are observed, right? And here when we draw the crystal field effect, these terms actually has the energy ordering as per Ohm's rule as 4G should least than the least after the 4F, and it next higher energy will be 4D, in next higher energy will be 4B. But in reality, in experimental results shows that the 6s is next, it is has net 4G as in next, thereafter it has 4P, and thereafter it has 4D, and thereafter it has 4F, right? This is how the energy sequence, and this particular electronic configured terms also violating the Ohm's rule. And thus when we are showing on one scale, the term energy scale, drawing term energy scale and crystal field energy scale, the 6s should follow by should next by 4G, 4G next by 4P, 4P next by 4D, 4D next by 4F. Here we know that the 4G upon crystal field effect, it has 9-fold state, it is 9-fold term it is. So thus 9-fold term upon crystal field effect, it will be splits into an 1G, EG, T1G and T2G, as in 4 energy states it will be get splits. Same to that, the P will be upon crystal field effect, it will become T1G, and 4D will become upon crystal field effect, it will generate EG and T2G. And we know that 4F upon crystal field effect, it will has A2G, T2G and T1G. Thus when we are drawing the energy levels with the effect of crystal field, they will be have this particular picture where the EG energy states are in horizontal with the crystal field energy scale. They will be horizontally have straight lines, has horizontal straight lines. The AG levels and T2G, sorry, AG levels and EG levels are horizontal. So 6S has AG, right? 6A1G, so that will be horizontal. The 4G also having an A1G as well as T2G, so thus two also getting in straight line, and D energy state also having an one EG in an, thus EG we have to show in straight line, and in F there is an A to G, that also we have to show in straight line. Thus all 5 lines will be in straight line, 1 2 3 4 5, right? After all getting those 5 lines, we have to draw the T energy lines, right? Where the T energy lines will be in curved, will be gets in curved, much more curved, right? In the Orgel diagram of D5 electronic configuration, the T energy states will shown in curved, right? Gets in curved nature, right? Moreover in curved nature. So there the T1G followed by T2G for the 4G level drawing, and for 4P level the T1G will be excites its energy level and reaches to the here, and T2G of 4D will get lowers its energy level, and 4T2G will get here, and T1G and T2G will be drawn for the 4F, and thus all drawing will be shown like this, will be gets this particular picture, right? Here once we observe the electronic excitations, once we observe the sextate ground state to electron excitation, it has to take place. The sextate spin multiplicity sextate energy level to excitation, even wherever it is taking the excitation, that reaches to the quadrate spin term. It will be quadrate spin term. It will be more higher energy states are all quadrate spin multiplicity terms. So as per spin allowed concept, the same terms, spin multiplicity terms, excitations only allowed. Different spin multiplicity terms, excitations, electron excitations terms will be forbidden. In same spin multiplicity terms, the electron excitation is allowed. In different spin multiplicity term, excitation will be forbidden. Here the sextate to quadrate, the higher energy states are all quadrate. So different spin multiplicity is there for the one state to other state. Ground state to higher energy states are different in multiplicity, spin multiplicity. So far electron excitations will be forbidden, that is the one. And another thing is, this particular picture diagram can be adapted in octahedral crystal field as well as in tetrahedral crystal field. There is no more differences, much more differences can be observed in octahedral crystal field or tetrahedral crystal field. So this is how the Orgel diagrams we can explain. So here I will stop. By next class we will going to have new chapter, right?